Hi, I'm Dr. Papya Bhattacharjee. In this problem, we have to apply Taylor's theorem to find the power series for the function e to the x centered at 1. And then, for the second part, we have to compute the radius of convergence. Now, for this video, let us just apply the Taylor's theorem and see if we can figure out what the power series looks like. Okay, so let me remind you what Taylor's theorem tells us. Okay, so Taylor's theorem says that a function can be represented by a series, a power series, and the series has this form. So you will have the nth derivative of the function evaluated at the center C divided by n factorial times x minus c to the n, and n from 0 to infinity. So this is the form of the power series for the function f using Taylor's theorem. Now, you see that we have our function, we have our center. All we have to do is figure out these various derivatives of the function and evaluate at the center. Okay, and then try to find this general nth term to rewrite our series. Okay, so let's start by taking various derivatives. So the function is e to the x. Okay, what is the first derivative? Well, we know exponential function, its derivative is itself, e to the x. Second derivative is again e to the x. Third, also e to the x. Now, you don't have to compute all these derivatives, but this is a simple enough function that all the derivatives are itself, and then we can say that if you continue, the nth derivative of this function will be again e to the x. But you realize that there can be other types of functions. They're not that easy to compute the derivatives. So it's a good idea to compute a first few and then look at the pattern and then write down the nth derivative of that function. Now, it might be even simpler to not write down the derivative actually, but what the value will be when you plug in c. Okay, so let's do that. So now for each one I'm going to plug in, the center is 1, so I'm going to plug in x equals 1 for each one of these expressions. So what is e to the 1? Well, that's e. For this one, it's again going to be e to the 1, which is e, and so on. So each of these derivatives, when you evaluate at the center, you get e. Okay, now let's see. Let's try to apply Taylor's theorem and write down the series. So e to the x is equal to summation n from 0 to infinity. Okay, so let me write down this expression one more time. So it will be nth derivative of the function at c equals 1 divided by n factorial, and then since c is 1, we get x minus 1 to the power n. Okay, so far so good. Now let's see. What do we have for fn1? That's the nth derivative at 1 is just e. So we just rewrite e here over n factorial x minus 1 to the power n. So this is the power series for e to the x centered at 1 using Taylor's theorem. So this completes the first video. In the next one, we will compute the radius of convergence.